Okay, we're going to solve more inequalities. For the most part, today's are a little bit harder than what yesterday's were, but we'll walk you through this so it'll still be quite doable for you. Now, to solve something like this, just like if it was an equation, we'd want to get 0 on one side, and then we could factor the quadratic formula. Now, we do have an inequality rather than an equation. What is in our parentheses that makes it 0, so like -3 here and 7 here, I refer to as our critical points. They divide your number line into regions that work and regions that don't. So if we put a number line down, and yes, mine's covered up, but draw a number line, put down -3, put down 7, then we're going to try a number from each region to see if it works or doesn't work. You could try it into the original. You could try it into any of these inequalities along the way, but I'm going to go ahead and try it into the factored one. I like using the factored one. I could try a number over here like -4. -4 plus 3 is negative. -4 minus 7 is negative. A negative times a negative we know is a positive, but I'm looking for something less than 0. I just tried something, I got a positive, which is not less than 0, so I don't shade here. Then I could try something in between, like 0. If I try 0, 0 plus 3 is positive, 0 minus 7 is negative, positive times a negative is negative, and that's what I'm looking for because I want less than 0. So I tried a number in between, and it worked, so I'm going to shade in between. I could try a number to the right, like 8. I could even try 8 billion if I wanted, but 8 plus 3 is positive. 8 minus 7 is positive. Positive times a positive is a positive, which does not work because I want something less than 0, so I'm not going to shade. Now I'm going to write my answer off of my number line. Square, -3, 7 with a square. Same type of thing here. We're going to get 0 on one side. We're going to factor it. Second one is differences of squares. This first one, if I square something, it's 0 or positive, and add 16, the green is always positive. So my critical points I get are from the dark blue. So I'm going to put both the 1 and -1 on my number line, and then I'll try a number in each region to see what works. I'll try something to the left of -1, over here like -2. And once again, we had already said that this one here, no matter what you put in, will always be positive. Then -2 minus 1 is or -2 plus 1 is negative. -2 minus 1 is negative. Positive times a negative we know is negative, times another negative is positive. But we want something less than 0, so that means we're looking for a negative. We just tried it, and we get a positive, so it doesn't work. So I'm not going to shade over here. We could try something in between, like -1/2, positive 1/3, or we could just try something like 0. So if I try 0, which is in between, that's always positive. 0 plus 1 is positive. 0 minus 1, a positive times a positive is a positive, times a negative is negative, and that's what we're looking for. So I like that, so I'm going to shade in between. Then I could try a number to the right, like say 2. And if I try 2, that's always positive. 2 plus 1 is positive. 2 minus 1 is positive. Everything's positive. I get a positive answer, but that's not what I'm looking for, so it doesn't work, so I'm not going to shade. So then I'll write my answer off of my number line. Curve, -1, comma, 1, curve. It's curved because there's no equal to in our problem. So what happens when you go ahead and have variables in the bottom? Well, you're going to go ahead and solve the normal inequality like you would normally. You're going to treat it like an equal sign. You're going to see what happens that causes the bottom to be 0 and what happens to cause the top to be 0 since we have a 0 over here. So the bottom factors, you're going to get the critical points from what causes the bottom to be 0, which would be 4 and 3. Oh, that's a mistake. Just a second. Now, I'm going to make note that 4 and 3 are from dividing by 0. I never can divide by 0, so whenever I have critical points from dividing by 0, those are always curved. I also want to look at what would cause the top to be 0 for my other critical point, and that would be -5. So I'll put -5 on the number line, I'll put 3 on the number line, and I'll take and put my other critical point of 4 on the number line. So now I want to try something to the left of -5 from my number line, like -6. So if I work this out, -6, -6 minus 4 is negative, -6 minus 3 is negative, -6 plus 5 is negative. According to this fraction bar, I got to work out the bottom. Well, a negative times a negative is a positive. Negative on top divided by positive on the bottom is negative, which is less than 0. So that means it's going to work. So I tried a number over here and it works. So I'm going to shade. Now I could try a number in between, like 0, or any other number I wanted. 0 minus 4 is negative, 0 minus 3 is negative, 0 plus 5 is positive. The bottom is a negative times a negative, which is a positive. Positive on the top over a positive on the bottom is a positive answer, but that doesn't work. I'm looking for a negative. So, doesn't work. Sorry. There we go. We don't shade. Then we try something in between, like 3.5. So 3.5 minus 4 is negative. 3.5 minus 3 is positive. 3.5 plus 5 is positive. So on the bottom I multiply, I get a negative. Positive over a negative is a negative, and that's what I'm looking for, so that means it's going to work. So I'm going to shade in between. Try a number to the right of 4. Well, if I try a number to the right of 4, that means no matter where I put stuff, everything ends up being positive. If everything's positive, I get a positive over a positive, which is a positive. I'm looking for something less than 0, so that means it doesn't work. So now I'll write my answer off of my number line. From -infinity to -5, which is square, union curve 3, 4 with a curve. Once again, the 3 and the 4 are curved because they're from the bottom, which is dividing by 0, and I cannot use those. Now the one that comes from the top, if this is a less than or a greater than, then it would also be curved. But the top has a greater than, or if it has a less than or equal to or greater than or equal to coming from the top critical point, you're going to have a square. So this one, there's a couple ways you could do it. You could set it equal to 0 and subtract your one fraction to the other side and write it as one big fraction. Then it'd be just like the last problem. Another way you could go ahead and do it is still go ahead and look at what causes the bottom to be 0 and then just solve the equivalent equation. So if you set this to 0, you get 3. You set this one equal to 0, you'd subtract 1, divide by 5. You get critical points of 3 and -1/5. Now, instead of taking everything to one side like it would be for the last problem, which would work perfectly fine, I'm going to put an equal sign in here and solve it. So now I'm going to cross multiply this times this times this, distribute through, then get the x's on one side, so subtract 3x from both sides, get the 1 on the other side. In this case, I get -5 as my other critical point. So I'm going to put all my critical points in a number line, divides my number line into regions that work and regions that don't work. Then once again, I need to go ahead and check this. Now, the reason I like to do it like I did earlier, where I had a 0 on one side with, in the factored form, it was easy to decide if it's positive or negative. and then just go from there. I don't have that here, so I need to actually go ahead and take a number like over here, -6, plug it in here, plug it in here, and then I'll have to go ahead and look at the decimals. So I'm going to go ahead and try -6. Oops, wrong thing. -6, and plug stuff in. So if I plug in -6, I get -3/29 on the left side. I get 1/9 negative on the right side. If I do the decimals, oops, I forgot a negative sign here, sorry. Now, I would then end up getting this to be a true statement because I want this one here to be greater than. If you look at a number line, this is farther to the right than this one here, so it does work. So then I could try a number in between, like say -1, and try -1 plugging stuff in. If I try -1, plugging it in here, I get -3/4. Plug -1 over here, I get -1/4. -3/4 is farther to the left on the number line, so it means it's less than this. And I'm not looking for that, I'm looking for greater than, so it does not work. So then I could try a number over here. I could try like 0. So if I tried 0 and plug that in, I'd have 3/1, or not 1 over, yeah, 3/1, which is 3. If I tried 0 here, I get -1/3. And I'm looking for the left side to be greater than, and I know a positive is greater than a negative, so it does work, so I'm going to shade in between. Then I could try a number on the right, like 4. So I'll pause and plug in 4. When I plug in 4, on the left side I get 3/21. On the right side I get 1. I don't even have to look at the decimals here. I know that 3/21 is smaller than 1. I'm looking for greater than, so I know it does not work. So then I go ahead and write my answer off my number line. Remember, if you have two totally separate regions at work, you join it with a union symbol.